Hey everyone. Today we are diving into one of the absolute biggest questions you can possibly ask. Just how big is the universe? Seriously, it's a question that stretches our minds to their limits, blending numbers so big they're almost meaningless with ideas that are, well, just completely profound.
So let's just get right to it. Is this whole cosmic thing we're in, is it endless? Does it just go on and on forever? Or does it actually have an edge, a size that we could, at least in theory, put a number on?
And look, I've got to be straight with you right from the start. We don't know for sure. I know, that's kind of frustrating, but honestly, that uncertainty, that's exactly what makes this whole quest so unbelievably exciting.
Because we're like cosmic detectives, piecing together clues from the faintest, most ancient light to the very fabric of space-time itself. It's a mystery story on the grandest possible scale. So let's start with what we do know.
Okay, first things first, we need to make a really important distinction. See, when you hear scientists talking about the size of the universe, a lot of the time they're actually talking about the observable universe. And it turns out there's a hard limit to what we can see.
So, what is that limit? You want a number? Here you go. 92 billion light years. It's a number so big it just kind of breaks your brain. But what in the world does that actually mean?
That massive number, that's the diameter of our personal little cosmic bubble. It's the region of space where light has actually had enough time to travel and reach us since the Big Bang happened 13.8 billion years ago. Now, you might be thinking, wait a minute, if it's 13.8 billion years old, shouldn't the diameter be, 27.6 billion light years? And that is a fantastic question, because the answer gets to the heart of it. The universe itself is expanding. The actual space between us and those distant galaxies has been stretching this whole time, pushing them much farther away than their light's travel time would suggest. Anything beyond that 92 billion light-year sphere is past our cosmic horizon. We can't see it. We will never see it.
So, what about the whole universe? The part beyond our bubble? Well, to even begin to answer that, we have to talk about its shape. And I don't mean shaped like a star. I mean the fundamental geometry of space-time itself.
Turns out, Einstein's theories give us three main options. We could have a closed universe with a positive curve, kind of like the surface of a sphere, or a flat universe with zero curve, like a giant sheet of paper, or an open universe with a negative curve, shaped like a saddle. And get this, the shape is directly linked to its ultimate fate. A closed universe, for instance, would eventually stop expanding and collapse back in on itself in a big crunch.
And this leads to a seriously mind-bending idea. Something can be finite, but have no edge. Think about the surface of the Earth. It has a finite area, right? But you can fly in a straight line forever, and you'll never hit a wall. You'll just come back to where you started. A closed, spherical universe would be exactly like that, just in 3 dimensions instead of 2. Whoa.
So which one is it? After decades of incredible measurements, looking at the faint afterglow of the Big Bang, all the evidence points to one stunning conclusion. Our universe appears to be almost perfectly flat. This is a huge deal. Flat is the knife's edge between a universe that collapses and one that expands forever. It could mean the universe is truly infinite, or it could just be so ridiculously, colossally huge that our little observable patch just looks flat to us, the same way Kansas looks flat even though you're on a giant curved planet. It could even be a finite but more complex shape, like a 3-dimensional cosmic donut.
All right, let's step back for a second and ask a much simpler question, one you've definitely thought about. Why is the sky dark at night? It seems almost childishly simple, but the answer is one of the most powerful clues we have about the true nature of our universe.
This amazing little puzzle has a name, Olber's paradox, and for hundreds of years, it completely stumped astronomers. It was this perfect little logic trap that seemed to prove the universe just couldn't be infinite and eternal.
Here's how the logic goes. Just assume for a second the universe is infinite, has always existed, and is filled with an infinite number of stars. Well, in that case, no matter where you looked in the sky, any direction, any tiny point, your line of sight would have to, eventually, land on the surface of a star. Every single dot in the night sky should be blazing with light. The whole sky should be as bright as the sun. So, why isn't it?
The answer is that the paradox's basic assumptions are just wrong. The simple fact that you can look up and see darkness is proof that our universe had a beginning. Because it's only 13.8 billion years old, light from stars that are super far away just hasn't had time to get here yet.
And on top of that, the expansion of space itself stretches out the light from distant galaxies, shifting it into wavelengths our eyes can't even see. The dark night sky is literally proof of the Big Bang.
Okay, so this brings us right to the bleeding edge of what we know. If our universe had a beginning, what does that mean for the idea of infinity? What, if anything, came before the Big Bang? And this is where we get into some of the most mind-blowing and fiercely debated ideas in all of science.
So, theory number 1 is that our Big Bang wasn't the beginning, it was just a beginning. This is the multiverse idea, that our entire universe is just one bubble in a vast, endless cosmic foam. This idea comes from a theory called eternal inflation. It basically suggests that the crazy fast expansion that happened right after our Big Bang is still happening out there, constantly spawning brand new bubble universes. And each of those bubbles might cool down with its own unique set of physical laws. Our universe, then, is just one of a potentially infinite number of different realities. According to Alan Guth, who's one of the architects of this whole theory, the multiverse isn't just some wacky fantasy. He says it's a natural, almost unavoidable consequence of the math. So in his view, the more we prove inflation happened, the more we have to accept that we're probably not alone.
But not so fast. Paul Steinhardt, another one of the pioneers of inflation, argues the exact opposite. He says, look, if there's a multiverse where literally anything that can happen does happen somewhere, then your theory doesn't predict anything specific. And if you can't test a theory, is it really science? This is a huge debate raging at the frontiers of physics right now.
But there's another, totally different grand idea. What if our universe isn't just one of many that exist at the same time, but is actually just the latest in a long, endless chain of universes, one after another? This is called the cyclic model. The idea here is that the universe goes through this eternal cycle of birth, death, and rebirth. A Big Bang kicks things off, the universe expands for billions of years, then it eventually collapses back on itself in a big crunch, which then bounces into the next Big Bang, starting the whole process all over again, forever. This is such a cool alternative, right? Instead of being infinite in space, like the multiverse, this is a universe that's infinite in time. Some of the modern versions of this idea, which come from things like string theory, even suggest that our Big Bang is caused by the collision of two higher-dimensional membranes, or brains. And these newer models have figured out ways around the old problems, suggesting this cosmic cycle really could go on for eternity.
And that leaves us right here, standing on the edge of what we know, staring at this incredible final question. Is our universe, this vast, flat, 13.8 billion-year-old home of ours, just one tiny bubble in an infinite cosmic ocean? Or is it simply the latest chapter in an epic story that repeats itself for all time? We don't have the answer yet, but what a question to be asking.